All right, it's time, so let's go ahead and start. There's no new announcement today, but I did edit the announcement on Tuesday. So quiz 26, 27, 28, and 29, which is popping up today, will be due at the end of the week. But you know what to do. Just go to the Slack channel and then type up your answers. And today we're gonna reserve more time for the quiz 29 there. Okay, it's a very interesting quiz. All right, so the topics today, so essentially we'll go over 3 videos. First one is actually to just wrap up DHCP we have started on Tuesday, and it's primarily an example of DHCP. So that's a recap a little bit, okay, DHCP. So I need to go here, good. So you see that DHCP essentially is the mechanism we use to get an IP address coming to a random subnet. Okay. The exchange of the messages there to enable acquiring an IP address dynamically is very simple, right? So you see here, we do first discover message from the client coming to the subnet. And then the DHCP server will provide an offer, okay, sending back this message, DHCP offer. And with the offer message, there comes an IP address offer to the client. The client then say, okay, I'm gonna take it in the DHCP request message. And finally the server act, okay, the request or reply to the request. So this is the formal process of DHCP. But you see also these 2 messages, okay, are optional. Okay, usually when you come to a new subnet, these 2 messages will be necessary because you have no idea what is the subnet address space. So usually you ask first, discover first. But if you are already in a subnet for a while and you just need to renew the lease, okay, so every time you are offered an IP address, that offer is actually limited by time. So there's a lease for it, and associated with the lease is also a time duration. So when the time duration expires, you need to renew the lease. Okay, so when you are renewing the lease, you don't really need to discover again because you kind of know already what the subnet is about, right? The range of IP address, the DNS servers and things like that. So you can do away with a very short exchange, just request and act. So that's when you do the simplified DHCP exchange. So that's a quick review. Now, let's go on to an example of DHCP working, particularly the simplified version. And to illustrate, you see in this DHCP example, host is right here. Okay, we just joined. And DHCP server is already up, and it happens to be running on the first hop router. So what happened there is, the connecting laptop is going to send a DHCP request message out to the network. So this is the simplified version of DHCP. Sending request and server sending ACK. So the laptop here is asking for its IP address. In addition to that, first hop router, DHCP server, and Dynamically. So DHCP is actually right here, an application layer protocol. And that DHCP discover or DHCP request message is going to be what? Passed to the UDP and adding the UDP header, push down to the network layer and adding the IP header, and push down to the Ethernet and adding the Ethernet header and trailer. So the DHCP request gets encapsulated into an UDP packet, further into an IP packet, further into an Ethernet frame. So DHCP is actually implemented at the application layer. Just like DNS, seemingly a lower level functionality, a general functionality, okay, for everyone on the internet, but implemented at the application layer. Complexity at the edge. And it's using UDP as the underlying transport layer service. Now this frame, carrying destination address being broadcast 255.255 all the way, is going to reach all the hosts on the subnet. So this is the entire subnet. By the way, this is a Ethernet switch. It's a rectangle, not quite a circle. So this is not the router. Okay, so yeah, this is actually the link. Okay, so this interface and this interface are connected through this link. So every host on the subnet is going to receive the DHCP discovery message. So therefore, the server here is going to pick it up. So this is what going to be extracted, okay, and pass up to the IP layer. This extracted, pass up to the UDP, and this extracted, and eventually reaching the application layer. So the server then can see, this is a request message, therefore send back a reply. So you see here, going all the way, Ethernet gets demuxed to IP, to UDP, and finally, server side of DHCP. The server then will generate the ACK message containing the IP, containing the IP address of the first hop and the IP addresses of the DNS servers, and so on and so forth. So process is very similar, encapsulate to UDP, encapsulate to IP, Ethernet, and destination address being broadcasted. Yeah, the host here, although not having a specific IP address, is gonna pick it up. So client now knows the IP address of itself, name and IP address of the DNS server, and the first hop as well as what the network mask. So what I'm showing here is the result of sniffing DHCP messages. This is a DHCP request message, and this is a reply of that. Earlier we actually called it the ACK packet, okay, ACK message. And I can use tools like Wireshark or TCP dump to sniff packets travel the internet. Now, after sniffing, you're gonna see the content inside the packet. So what I'm showing here is, yeah, this is the request message. So you see boot request. And in the reply or in the ACK message, you see it says boot reply. And you see transaction ID, transaction ID, and they're identical. So this ACK here is for this request. And then you see also specifically the client not having an IP address, but it still have a MAC address. So that MAC address is actually hard-coded into the network interface card that came with your machine. Okay, so that is already existing. And that is something that the DHCP client is going to send to the server. So server can identify you somewhat by the MAC address. And then, yeah, this is DHCP request, okay, and this is DHCP ACK. And the client is asking for these, right? So the IP address, okay, so IP address is not clear yet, so requesting, yeah, this IP address. Okay, so this is not a sure thing. It's just that the client suggesting, can I get this IP address? And it's also asking for domain name servers, and the subnet mask. Server here, in the response, you will see, okay, hey, client, okay, it's okay to use this IP address. Go ahead. In the meantime, it's returning also the subnet mask, the first hop router, as well as the IP addresses of the DNS servers and the domain name. So all these information, client can then set everything up and then begin to access the internet. All right, and that takes us to the Q&A first, and then we go to the quiz. So last time, Tuesday, I think Jean asked a question. Will different clients send the same transaction ID? Yeah, there's a slight chance. Okay, it's a good question, by the way. But the chance is very low because these transaction IDs are more or less random numbers. Okay, but the chance gets higher when there are more clients around there asking for IP addresses. All right, good. Now then we move to the quiz, number 29. Okay, so this quiz is a little bit long. Okay, so I don't know if you have experience using the Taipei free Wi-Fi. Okay, so there are quite a few these free Wi-Fi services around. particularly not just Taipei, but also in other major cities where there are a lot of tourists. Okay, let me know what your experience using Taipei free Wi-Fi, if you have any. Okay, so that will be your personal experience. So what I'm talking about here, so I'm quoting a report on the news. So this is a report. This is a report about free Wi-Fi, Taipei free usage. Okay, so it turned out. So let me translate it into English here. So it turned out. So quite a few of us are not satisfied with the service. So about 40% of the users are not really happy with the service. Okay, among these not so happy users, 74 of us complain. Hey, we couldn't even connect at all. Not to mention that the connectivity might be bad, or the connectivity is somewhat intermittent. So meaning sometimes connected, sometimes off, on and off. Okay, mass majority of the complaint is this: we couldn't even get connected. All right. Now we just finished talking about DHCP. You see, Taipei TPE free is a free Wi-Fi access. That is also saying that every time you're using it, you're using DHCP to connect to the Taipei free subnet. Okay. And DHCP is the first thing you need to do in order to get connected. Okay. So there's something wrong there in the DHCP exchange. Okay. Q1 here asks, what do you think might be causing the trouble? How come these 74% of people are saying that, hey, I have even trouble connected to Taipei free? And Q2, how would you address the problem? Okay, given what your guess is, okay, the trouble is. So I guess this is the question that you might want to find your teammate. Okay, so I don't know how you do it, but try to find your teammate. Maybe set up a line chat channel, or hey, direct message them on the Slack. Okay, so I'm gonna give you more time for the quiz because it's gonna take some time to brainstorm. So let's say, how about 10 minutes? So find your teammate. I don't know, can you do direct chat? Direct three-way chat? I guess that might be the challenging part in case you have in case your team has more than 2 members. So let me go to the channel for quiz 29. There. So it doesn't look like you can set up a 3-way direct message, unfortunately. So let's focus on Q1 first. So what do you think the trouble is? I think it's okay. Why don't we just focus on Q1 and you guys can just type up your answer for it. Yeah, very good. So Samuel there is demonstrating. Okay, just get the A1 first. So Team 12 is suggesting it might be that the subnet IPs are not enough for the many users looking to connect. Very interesting. Yeah, I guess that might be very much the case, because free Taipei or Taipei free is usually what you attempt to connect when you are, for example, in public space, like a metro station, like the train station, or in the airport. And we are kind of all coming and going. So I might have connected to the Taipei free, but I left shortly. I mean, moving out of the subnet quickly. But I already occupy one of the IP addresses, isn't it? Good point there, Samuel. So let's see, Jia Hong. Maybe bandwidth is not so big, so many users simultaneously, or DHCP server capacities is not enough. Definitely that's very possible. And not to mention that DHCP messages, right? The request and reply are being sent using UDP. If you have experience accessing public Wi-Fi, you see that a lot of times the bandwidth is limited there. If you're using 4G, for example, in public space where it's very crowded, you see also bandwidth being limited. You don't get the regular bandwidth. And if many are doing DHCP simultaneously, you can imagine the packets collide to each other. And UDP says, hey, packet drop is packet drop. So it might take a long while to really get connected to the server. Similarly, the server could be very busy. So you feel like, hey, you couldn't connect, but maybe packets get dropped, the server is not quite yet responding, and yet you need to move away. So that's two other possibilities. Network, very busy, or server, very busy. That's great. Let's see, James and Yoda. Maybe there are too many people wanting to connect to the Wi-Fi at the same time. So the queuing the routers are very, very long, Exactly, this is the server busy possibility. Okay, so maybe the UDP packets are coming through, but these requests get queued up at the server side. Yeah, that's very possible. Oh, okay. Wow, James is typing up the answer for Q2. Let's see. To address the above problem, maybe we can increase some... interesting. Interesting. So maybe we'll break these subnets in the public space into smaller SSID, smaller Wi-Fi clouds, smaller Wi-Fi cells. So that in each cell there is a DHCP server or a Wi-Fi base station, Wi-Fi AP. Okay, so that within a smaller cell, the capacity of the server will be more than enough. Okay, good. Let's see. Oh, Double Jelly. Double Jelly is replying to yourself. Okay. Also after one receive. Okay, let's go. Okay, interesting. It's a little bit long. Let's go over this. Maybe if everyone set their phone to auto-connect to the Wi-Fi too, much device will occupy the internet server. Actually, I do that. I have my iPhone's Wi-Fi automatically explore subnets and try to connect. I mean, even though some of the subnets request that you log in, provide username, password, and additional information, but DHCP might still be happening. You see, I think that's the real trouble. DHCP server is able to give out the subnet is only number of devices are able to connect. Yeah. And if we are all auto-connecting, chances very high. They're already all taken without the users knowing they are connected. Very good. Also, after one receive an IP from the network and leave the network, the server will have to wait until the least time. Yeah, we talked about the allocation of the IP addresses. Very dynamic. And the reason that it's dynamic is because the allocation comes with the expiration time. Okay, so that is also called the lease time. So once that is allocated, the server will need to, honor the lease and wait until the lease time expires. Then we can offer the IP address to another user requesting. Yeah, so lease time could be something that you can manipulate on in order to time out a little bit faster. Okay, in a very mobile subnet. Very good. I like this one. Hey. Now, Jingyuan and Yuanxiang and Shiwei, DHCP server is overflowed since there are a lot of people trying to connect to it. Yep. Since the connection is established by UDP, very good. There's no congestion control, definitely, right? Yeah, here's where you see my BTCP working a little bit better. But you see, DHCP is something that we needed like right away, crossing a subnet. So it needs to work also fast. You can imagine if we use TCP for the DHCP messages, the way to get connected, to get TCP connected might be significant already. Alright. So sometimes between the trade-off, you choose one over another. Very good. Let me see, Junting. Maybe the IP address are not enough, or might be the server capacity is not enough. Very good. Yeah, so IP address not enough. Many of you mentioned that. That is very likely the case. But think about it, right? For most of the subnets we're using local addresses. Okay, so we're using fake IP addresses. Okay, much like when you are connected to NTU PEEP. Right, so you are given an IP address. You might never look at what is exactly the IP address, but you often get something like 192.168a.0.1 or something like that. So that's a very common IP address you see in home network, in public network, in Wi-Fi subnets. How come? Because we are all using these fake IP addresses. So when we're using fake IP addresses, the address space is not that limited. It's fake anyway. The admin can actually set it to a really, really high number. Yeah. So IP address might not be enough. That's one possibility. Okay. But one can actually expand the IP address by shorten, right, the prefix. So maybe more serious is the server capacity. Okay. So many requests coming in and going out. Okay, so Double Jelly is typing up your answer for Q2, isn't it? Shorten the lease time. Then we can quickly reclaim the IP address that are previously issued out. Very good. And I like this. Okay, so how about a pack of fries? Okay. Okay, Suwei now speaking for team 2. Add more DHCP servers, definitely, right? So that's divide big Wi-Fi subnets into smaller one and having multiple APs, and therefore we kind of also divide the load. Very good. Wei Sheng here speaking for team 3. Too many users try to, you see, team 3 is great. This is the root cause, isn't it? Too many of us asking to connect, okay? And too many of us not aware of that we are configuring our phones or our laptops to automatically connect without us knowing. Okay, so if you are asked to configure your Wi-Fi by choosing from two options, whether you automatically connect or you need to confirm. Otherwise, your laptop does not connect. Try to do the later one. Okay. The subnet's IP address or connection bandwidth may not be enough. Yeah, exactly. Okay. Oh, to address this issue, right? If there are so many users connecting to Wi-Fi, constrain the connection time. I guess this is probably also the least time. Only connect for 20 minutes once. If the connection is idle for more than 15 minutes. Oh, interesting. So there's like a hard limit whether you're using it actively or not. After 20 minutes, they are automatically kicked out of the subnet, all right? And the second one is more saying if they are idle, not using it, that's give a shorter expiration time. Okay, and I like the design. Okay, it makes a lot of sense and a little bit more adaptive. So we can kick the idle users out of the subnet faster. Very good. Okay, I like this. Okay, live long and prosperous, Team 3. 玉泽and Jingxiang, okay, Team 10. Too many clients are trying to connect at the same time. Yeah, okay, root cause. Okay, too many clients. The bandwidth is not enough, or the bandwidth of the server is not enough. Very good. And of course, it could be also IP address shortage. Guangzhao here speaking for Team 4. Number of DHE servers too low, so DHE servers are too busy. Very good. Add more servers, broaden the bandwidth, add more buffer space. Very good. Okay, so you have now a good idea that when there's more demand at the server side, there's going to be a queue. So it's a very common phenomena. It not only happens on the internet, it happens in the regular traffic network. It happens when you go to a restaurant. It happens when you go to a bank. It happens when you're waiting for for the elevator to come. Okay, so queuing is a very general problem. Okay, so if you discover courses saying queuing theory, 排队理论, there's a whole class of math surrounding figuring out what's going to be the wait time. And how are you going to expand the service rate so that we could limit the wait time, okay, waiting time or queuing time. Angela here, Team 6. Yeah, too few IP addresses available. Or the network is congested. Or part of the network is also the server capacity congested. Okay. We may try to increase the number of IP addresses or decrease the lease time. Okay, this is very complete, isn't it? Increase the number of IP addresses or decrease the lease. Or we may also try to implement share IP addresses. Interesting. Very interesting here. So are you saying that we share IP addresses? Okay, some of the clients share the same IP address. Would that work? I think that will work in case that we are all friends of each other. In a way, we'll all get the messages we are looking. We'll be all receiving the data, okay, sharing the same IP address. So I'll be receiving packets that are supposed to be going to Team 6 as well. But if I'm a hacker, they're trying to sniff and pull a man-in-the-middle attack, then it'll be also very easy for me to do it. I guess you can do this for home network, where there's password protecting the subnet. Very good. I think this will also work for like a slightly larger, so mid-sized company. Very unique ideas. I like this a lot. So let me see. What should I? Okay, a mushroom. Jia Hong, I thought you answered. Oh, okay. So this is answering the second question. Because of free rider effect, Many free services from government always encounter this condition. Yeah, when it's free service, yes, you do have this, right? People crowd to the service and no one gets the service in the end. Maybe if someone donates government, they have priority to use, okay. Setting priorities, okay, differentiate among the clients, okay, who are requesting for the services. So those who contribute more gets priority, and those who contribute less, lower priority. I think that's a very good business model generally for a service that's commercial. For public service, it's a little bit hard to say. So maybe there can be a system crediting the public services you have done. Although it seems that Taipei Free is not so free at all. Yeah. In the end, free services doesn't guarantee you anything. All right, so some philosophical thinking here, and I like that. Okay, good. Eating. Oh, okay. Hey, things are popping up real quick. There are too many requests, so all the requests get stuck at the server's buffer. Yeah, capacity not enough. Also, DHCP can only offer so many IP addresses. Yeah, so you essentially see two limitations: IP address and capacity, whether it's network or server. To address the capacity limit, we need to expand the capacity. To address the IP address limit, one can, of course, expand the IP address space, but also there's another dimension, reduce lease time. Okay, we see earlier someone proposing like a differentiated reduction of the lease time, right? Active user versus not active users. More servers, shorten lease time. And this is team 1. Okay, Junting is providing the answer for Q2. From owner's side, add a better server. Oh, that works. Get a higher end server. Cut down the usage by limiting the user using time. Maybe 1 hour a day. Oh, okay. Now this is something different. So this is not strictly the lease time. This is saying that for each user, okay, you get only an hour a day. Okay, so once you get that limit, I'm gonna give the opportunity to other users, okay, who haven't been using much of it. So this might be a little bit more like the weighted fair sharing, or the strict fair sharing, fair scheduling. Okay, so in the scheduling part of buffer management, right, you see to schedule the next packet onto the link so that the packet can finally go out. That is also a queuing problem, a service problem there. You can borrow also ideas there to do the scheduling here. So this is actually to limit something that's a bit coarser grain, the higher level, the total use time of the user. But how do we identify a user, right? Isn't it? So if we think about how does DHC server identify a user, then because they kind of come and go, right? And they actually send a request to broadcast address because they don't have an IP address yet. So you cannot identify a user by the IP address because the next time they ask for an IP address, it could be different. So what do you think, Junting, will be a good idea to identify a unique user? So we're doing like brainstorming live here. Okay, in a very inactive way, but hey, I love this. Okay, so this is something very different as well. Okay, good. So if you come up with something there, let me know. Good. Has an account, I guess. Oh, sure. Yeah, so TPE free, yeah, I think they kind of ask for an email address. So they can identify you by email address, I guess. But then you could use your other email address to log in to get another hour. Okay, so that's one idea. So I like that. Anyone else? How do we identify a user uniquely? Oh, team 7 here. Okay, so Junting, or people who are interested in identifying a user uniquely, think a little bit more. Yeah, so one can use a different email address, isn't it? Oh, wait. Team 7. Okay, so down here. Since there are only limited IP addresses, some users cannot get the available IP address to connect. Sure. Yeah, so we do have a limit on the IP address space. Bandwidth sometimes might be shared by many users, okay, and maybe several routers. Yeah, if they are running on the same channel on Wi-Fi, indeed, they are sharing the same spectrum, okay, the electromagnetic wave spectrum. Yeah, so the bandwidth is even lower. That's why I say when an area is really crowded, you see that the bandwidth somehow is lower, because the way we are modulating bits onto this, in the air, on the electromagnetic waves are flowing in the air. Yeah, it's very unfortunately we don't have time to talk about the link layer. In that chapter, you get to see a little bit how the modulation is done. So we get to send digital content through these electromagnetic waves. Okay. And there are quite a few tricks there as well to get it to work efficiently. And then Nan I think you're Jason Nan. Let's see. Oh, did I get this? Oh, okay. I have not yet go through Team 7's answer for Q2. Add more IP addresses or limit the user's lease time or usage time. Maybe round robin. Make sure the users get a chance. Very good. So the queue there containing all these user IP address requests can be working in a round robin way. So we get around. But then, hey, how do you tell, right, the individual users from these requests? Okay, then we bootstrap to the question that Junting, so Junting and I were now brainstorming. Okay, think about it. Is there anything that's being unique from your machine? Try to use another bandwidth which is not so popular. Sure. Use another channel that is not so popular, or use another subnet. So maybe not Taipei free, but maybe HiNet free, things like that. Team 11 with Wei Yao, maybe the lease time is too long. Yeah, sure. IP addresses are depleted. It could be caused by other problems due to too many clients trying to connect at the same time. So actually, free Wi-Fi in Taoyuan works better, maybe because of the lower population. Oh, interesting. Very good to know. Yeah, I mean, in case you guys are bored in the summer, go do a study of all these Taipei free. And generate a YouTube video. Maybe people will be very curious about, okay, where in which part of the whole Taiwan these Taipei free, Taoyuan free, Hsinchu free, or Kenting free Wi-Fi works better. Observing that most of the possible reasons stem from too many clients. Yeah, trying to connect. This is really the root cause. We can establish more servers. Very good. Oh wait, there are things popping up here. Yeah, so I see you guys trying to answer I want to say cookie can help. Oh, cookie, yeah. Very good association there, Jingyuan. Yeah. Okay, also, but Yuanxiang is too shy. So Yuanxiang was the one that came up with the solution. I think that's great. Yeah, so the server can set up a cookie at the client. So for the subsequent request, the cookie is actually sent in the meantime. Very good. So the credit goes to Yuanxiang, I suppose. Okay. Boxun. Oh, all right. Boxun, that's a cool idea. So Boxun, definitely pay attention to the end of the video in the example, right? In the request message, there's the MAC address, and I mentioned that it's actually unique to each of these network interfaces. You will also see for most of the laptops today, there's a wired network interface so that you can still connect through the wire Ethernet, okay, to the internet. There is also Wi-Fi, okay, so that's another interface. You will see if you examine closer, there are two different MAC addresses, one for each. Yeah, so MAC address is another way of identifying the user, okay, or identifying the network interfaces. Okay, so even though now we have two interfaces, but you see if we use MAC address to limit 1 hour at most per interface, so that's 2 hours maximum, okay, for a laptop. Okay, that might be better than using email address. Okay. But cookie, very unique. It might just work, except for the case where a very capable user hacking the client side of DHCP and disabling cookie. All right, very good interaction here. So I think we had a very good idea of DHCP, isn't it? So let's move on to the next topic, hierarchical addressing. The video is gonna go a little bit long, so what I'm gonna do is probably stop at some point. Okay, so we could continue on with the hierarchical addressing next week. So let's go ahead and play hierarchical
addressing.
This is
how a host gets an IP address. We ask the system admin for one or DHCP server, which is configured by the system admin. The bottom line is, how does the system admin get a block of IP addresses so that the system admin can assign to individual hosts? So the next question we're asking is exactly that. How a subnet gets the subnet part of the IP address? The answer is quite straightforward. As we ask the system admin for one, system admin asks the higher level system admin for a block of IP addresses. So if we are customers of an ISP, we ask the ISP for the address block. What I'm showing here is an example. ISP owning a big block of IP addresses. Okay, so by big block, this is how big a block is. Now the prefix of the subnet address of the ISP is only 20 bits, so only up to here. Therefore, that allows us a bigger free IP address space. Now, if there are 8 customers, okay, subscribing from the ISP, organization 0 all the way to 7, ISP can further divide a bigger address space this way, extending the prefix by 3 bits. So that is pushing it further here. So 3 more bits being included into the subnet ID. Because there are 3 bits, so we could uniquely separate the 8 different organizations. But as a result, we get what? Less free IP space. Each now gets only this much. That is what? 1/8 of the original space. So we are splitting the IP address to 8 equal bits. And it is done very easy by just simply saying this extending from 20 to 23. Let's say if organization 7 here having 4 departments and each ask for equal share, then it will be straightforward, right? Extend from 23 to 25, the prefix lengths. So we'll be actually doing, something like this. Take 2 more bits here, and there are 2 bits, therefore we could identify 4 departments uniquely. And the IP address space is now down to 2 to the power of 7. Okay, 1/4 of the second level organization here. So you see, using the prefix there, by sliding it to the right, we actually create also a natural hierarchy in the IP address space and dividing the IP address space. Just like how human beings divide and organize bigger society to smaller society and even smaller society. So this type of addressing, the IP addressing, is also called the hierarchical addressing.
And we'll have time only to this part of the video. The time is reserved for Q&A. So essentially we are now in part 3. Okay, and we'll continue in the middle of part 3 next Tuesday. In the meantime, I see a question here in the YouTube chat. The free Wi-Fi of Family Mart, asks users to relogging every half an hour. This method might be helpful. I think in a way, this is to do more confirmed timeout, right? So if after a 30-minute, Family Mart asks the users to relogging, and if there's no logging in, so Family Mart will know for sure that the user is gone. Okay, so claiming back the IP address. So I think this is in a way to reclaim IP addresses a little bit faster. But I think this is also a way, just like what Junting has suggested, right? Using and maybe some sort of ID to log in. So in terms of limiting the user usage within a day, this might not be all that helpful, but they can definitely claim back the IP addresses a little bit faster. So half an hour is pretty long, maybe something a little bit shorter for Taipei Station where people are a lot more mobile. For Family Mart, I guess, I think the white collar, blue collar people having lunch in Family Mart is quite common, and they could be spending more than half an hour there. So 30 minutes lease time or relogging time seem reasonable. So in a way, if you'll be working as a network admin or deploying a Wi-Fi network for the government or for a enterprise, you might want to think about the usage, before you configure your server, or before you purchase the hardware such that it's capable of handling the load. So a lot of times all comes down to whether you know the usage more ahead of time. So use your frontal lobe, simulate what is the workload first. Then it helps for you to come up with the better design. Instead of people sending complaints, then you react to the complaints. Good, so that's all the time we have. If you have other follow-up questions, feel free to type up on Slack. In fact, I think hierarchical addressing is something that James asked earlier. So let me go back to Ask Us Anything. Yeah, so James actually asked when we were talking about table lookup, prefix matching, right? And we do see that there are multiple entries and the IP ranges overlap. How come? How can that be happening? Next Tuesday, James, the rest of the hierarchical addressing video, you will hear why. And it will still work as long as we do longest prefix match. Okay, good. So that's all for today. I see you next Tuesday. I need to go and stop the stream. Alright. Ciao guys.